right. Let's kind of look at this. So for the first one, segment AB, that's right here on the graph, we can either use the skills that we learned yesterday for finding distance on a number line. Guys, as a reminder, phones need to be put away and stay put away until the bell. You can find distance on a number line by doing the absolute value of x2 minus x1. Since we have it on a grid background like this, if it is a horizontal line or a vertical line, you can just count the boxes. You can count the spaces in between. So for segment AB, more or less than or equal to 5 units? Less than. So we have less than 5 units. If I count the hops in between, 1, 2, 3, this is 4 units here. Segment CD, I can't just count the boxes there because it's diagonal. And what we're going to learn today is how to calculate that precise distance. But I just want to kind of use what we already have. If segment AB, right here, is 4 units long, 5 units would be just a little bit bigger, right? What do you think? Segment CD, more, less than, or equal to 5 units? More. Definitely looks like more to me. So CD, I would say, is greater than 5 units. I think I said 4 before. I'm sorry, I meant to say 5. EF, this is vertical. Yesterday when we were looking at distance, we were looking only at horizontal, and so we did absolute value of x2 minus x1. When I'm looking at just a vertical line, I'd do it the exact same way, but instead of x's, I'd look at y's. So y2 minus y1 absolute value. Or, since it's completely vertical, I can just count those boxes. More, less, or equal to 5 units? More. This is greater than 5 units. So let's count those hops. 1, 2, 3, 4, 5, 6, 7, 8, 9. This one is 9 units. What about segment GH, this other vertical one here? Equal to, let's count that. 1, 2, 3, 4, 5 units. So yeah, GH is equal to 5 units. And what do we think about this other diagonal line, IJ? That one is equal to. I can't count the boxes since it's diagonal, but here in just one moment, after we talk about the distance formula again, we're going to come back and verify that IJ is exactly equal to 5 units. Yes? You can use Pythagorean theorem, yes. Distance formula is based on Pythagorean theorem, so that's where we derive it from, absolutely. All right. Keep your warm-up sheet out. Grab your books. We're going to be on page 29 for starters, and then we're going to go right back to this warm-up page because we're going to verify what we just said on number 5. 29, yes. Page 29. We talked about this bit up at the top right at the end of class yesterday, but I just want to kind of revisit it. When we were doing horizontal distance on a number line, we did absolute value of x2 minus x1. What does absolute value do to numbers? Turns them positive. If they're positive, it leaves them alone. If they're negative, it drops that negative sign and makes it positive. Do you guys remember why I said we are squaring these? Yes. Squaring is very similar. It's another way to take a number and force it to be positive. It's not going to just drop that negative sign out in front, but if I do a negative times a negative, I'm going to get a positive number. If I do a positive times a positive, it's going to stay a positive. So it's another way of forcing numbers to become positive. x2 minus x1, we said that's our run, like when you guys did slope in Algebra 1. y2 minus y1, that's our rise. So we're going to take the run, we're going to square it to force it to be positive. We're going to take the rise and we're going to square it to force it to be positive. So I'm going to have two positive numbers, I'm going to add them together. Because both of those numbers that I'm adding together, though, have been squared, it's going to be pretty big. So to undo the squaring that I did to them, to get them back down to their real size, at the very end of it all, I'm going to take the square root. This is why you're going to need those calculators today, because we're going to do the square roots of some of these different numbers. All right, look back at your warm-up page. We're going to look from I to J. And we're going to do rise and run here, since I can just count it on this grid. We'll practice on the next example doing it from just ordered pairs and practicing it algebraically. But I want to look at segment IJ. We're going to do the run squared plus the rise squared. Can you guys help me count the run and the rise? Run is going to be how far left or right I have to go to get to the next point. So I'm going to start at I, and I'm going to count the hops that I would make just straight horizontally. So 1, 2, 3, 4. Should I keep going or am I right above point J? Should I go any further, or if I stop right here, am I right above point J? Stop right here. So what is my run? Run is 4. So underneath that big long square root sign, my run is 4. So I'm going to have 4 inside parentheses, and I'm going to square it. Plus, let's count that rise now. So starting from right here, I'm going to drop down until I get to point J. How far is my rise? 3. 1, 2, 3. Since I went down, should I call that a positive or negative? Think about your slope from Algebra 1. Negative. So rise, since we went down, would be -4. So that's what I'm going to put inside. Sorry, not -4, -3. I had 4 on the brain there. My apologies. Rise is -3. So I have -3 inside my parentheses here. What do I get if I take 4 and I multiply it by itself? 4 squared. 16. Be careful on this next one. -3. To square something means to multiply it by itself. So -3 times another -3. 9. Pause right here for a second. Grab your yellow calculators. With no parentheses involved, I want you to push -9 and then the squared button and hit enter. And tell me what your calculator says. -3 and then hit the squared button. I meant to say -3, my apologies. I'm trying to repeat. It says -9. But what does it mean to square something again? What does it mean when we square something? What are we doing? Yeah, it should force it to be positive. Do -3 times -3 on your calculator. That gave us a +9. So why is it that we do -3 squared and it gives us the wrong answer? Here's why. Your calculator is a stickler for order of operations. What's order of operations again? PEMDAS. What's the P? Parentheses, then exponents, then multiplication and division, and finally addition and subtraction. When you put in -3 and then you hit the squared button, your calculator says there's no parentheses, so I'm going to jump right to exponents. It squares the 3. It doesn't pay any attention to that negative sign out in front because it treats the negative as multiplying by -1, which it does after it multiplies the 3 by itself. If you want your calculator to take the -3 times itself, you have to put parentheses around it. Try it with parentheses in your calculator. Do parentheses, -3, close them, and then square it. 9. Absolutely have to have parentheses around it if it's negative. To keep myself from making mistakes when I'm squaring numbers, I always put the parentheses around it so that I just get in that habit and my calculator never gives me the wrong answer there. All right, enough with the calculator mechanics. What do I get when I add 16 and 9 together? 25. What's the square root of 25? 5. So segment IJ is 5 units long, which is exactly what I told you the answer was there. Let's try the problem that's in your book, where we're going to practice this exact same skill, but instead of counting my run and my rise, we are going to calculate it by doing x2 minus x1, y2 minus y1. So we're still on page 29. We want to find the distance between point J and point K. We're going to let point J, which is 4, 3, be the x1 and the y1. Please label this right above these numbers in your book. Label the x1 and the y1. And then we're going to let point K be point 2. So that ordered pair, -3, -7, that's going to be my x2 and my y2. I always, still, after 10 years of teaching this and after more years than that of doing math, when I'm finding the distance, I still label my x1 and y1, x2 and y2. Because if I don't, I make some really stupid, easy to make mistakes that I know better, but I still do it anyway. You guys want to know what my most common mistake is? My most common mistake is I look at this ordered pair and I call this x1, but then I call that x2. But an ordered pair has an x and a y, so it has to be x1 and y1. This is why I go back and label them, because then if I make a mistake going through my problem, if I have them labeled and I've labeled them wrong, I can easily find my mistake, because I know every ordered pair has to have an x and a y in it. So please go in and label your ordered pairs. All right. Let's fill in our distance formula. We're going to do x2 minus x1 inside the first set of parentheses. What number are we putting in for x2? -3. What number are we putting in for y2? -7. All right, I've got my x2 and y2 filled in. Let's fill in the x1 and the y1. What is x1? 4. What is y1? 3. Now I need to simplify these parentheses. Take just a minute, think about it carefully. Whenever I've got negatives and then I'm doing adding or subtracting, I think about myself on a number line. So when I'm looking at the x2 minus x1, that first set of parentheses, I'm standing at -3 on the number line. When I subtract, I go left. When I add, I go right. So -3 on the number line, and then I'm going to -4. So I'm going to take 4 steps to the left. Where would I be on the number line now? -7. So I have -7 inside this first set of parentheses. What about when I simplify the second set of parentheses? -7 minus 3. -7 on the number line, and then 3 more to the left. -10. Sometimes I draw myself a little number line and I count my hops if I'm not quite sure, especially if I don't have a calculator handy and I'm afraid of making mistakes. -7 squared means to take -7 times another -7. What's -7 times -7? +49. What about -10 squared? -10 times itself? 100. And then 49 plus 100 is 149. We should always be ending up with positive numbers underneath our radical, and we should be adding 2 positive numbers together. Grab your calculators for me. We're going to take this, we're going to put the square root of 149 into your calculator. So you guys remember how to get to the square root key on the calculator. Look for the green button that says second. Do you see that button? Push the green second button, and then go down until you see the x squared button, and push that. It should put a radical symbol on the screen. So green second key, and then the x squared button, and then put in 149. Yep, that's absolutely right. Hit enter for me and tell me what you see. Square root of 149, well that was helpful. Look at the enter key that you just hit to get that answer. That white enter key. Do you see another white button right above that that looks like arrows pointing to the left and to the right? Hit that button and it'll turn it into a decimal for you. What's it give you when you make it give you the decimal? 12.2. Normally, I take things out to 2 decimal places. So normally I would do 12.20 or 12.21, depending on my rules of rounding there. I'm fine if we write 12.2 because that line is only so big. But 2 decimal places is usually my minimum. If we have a decimal point and then it's a 0 right after that, then I usually go out 3. Because I want to see 2 numbers, not just zeros after the decimal point. So far, so good? All right. Let's do the check problem down at the bottom of the page, and I want to do this one together. So we want to find the distance between A and B. So the distance between A, B, that would be represented by A, B, and then equals. Big, long square root here. I'm going to have a set of parentheses that are being squared, plus another set of parentheses that are being squared. This one right here is going to be my run. This one over here is going to be my rise. Yes. Yes. We need to pick out which point is going to be point 1 so that I have x1 and y1. Which point is going to be point 2 so that I have x2 and y2. Since they told us the letter A first, are you guys okay with that being point number 1? All right, so here's point 1. So that means on my graph here, here's A, so this is going to be x1 and y1. Since they gave me point B second, I'm going to let that be point 2. So that ordered pair is going to be my x2 and y2. How do I do the run here? x2 minus x1. What's my x2? 5. So 5 minus, it's always going to be minus after my x2 or my y2. And then I need x1. What is x1? -6, since it's a negative inside parentheses here. 5 minus -6. Second set of parentheses, I want y2. What is y2? 9. y2, 9, minus y1. What's my y1? -4. So inside parentheses, -4. When I subtract a negative number, what happens to it? Positive. So this becomes 5 plus 6 squared. The other set of parentheses becomes 9 plus 4 squared. What's 5 plus 6? 11. So I have 11 squared plus, what's 9 plus 4? So I have 13 squared. So again, this would be my run. This would be my rise. Since I have a graph, I can go in and check that by counting, right? going to go and do that. My run from point 1 to point 2, they're counting by twos here. So if I start over here, 2, 4, 6, 8, 10, and then 11 if I go halfway in between. So it's 11 if I'm counting by twos on those hops. My rise to get from point 1 to point 2, again, they're counting by twos. So 2, 4, 6, 8, 10, 12, 13. Since it's halfway in between there, it's not falling right on a line. So my run is 11, my rise is 13. Let's square both of those. Grab your calculators if you need to. What is 11 squared? 121. Plus, what is 13 squared? 169. And what do I get if I add those two together? 290. Take the square root of that in your calculator. I got 17.02, or depending on how you round that, because I think there's a 9 after the 2, right? So you could say 17.03. I would accept either one of those as correct. Or you could do 17.029 and get out to 3 decimal places. Before we flip the page, I want you guys to label these real quick. When we leave things with a radical around it, because it did not simplify, it didn't come out to be a nice pretty number when we did the square root, we would call this our exact answer. Once we have had to round our answers, because it didn't come out perfect, we would call this the approximate answer. Most of the time, for what we're going to be doing, tests, quizzes, for your test that happens next week, it's a week from today. Next Friday is your first test. The approximate answer is going to be fine. That's when you take it out to 2 or 3 decimal places for me. But if you ever see or read, or they want your answer to be left in exact form, I'm going to put it in my calculator first to see if it comes out perfect. And if it doesn't, then I'm either going to write it down in the reduced form that my calculator gave me, or I'm going to leave it looking just like I had here. Go ahead and flip the page. We're going to do this next part a little bit backwards. We're going to do the check that's down at the bottom of the page together. And then you guys are going to do example number 4 on your own after we've gone over this one here. Manuel wants to go snowboarding with his friend. The closest ski and snowboarding resort is approximately 20 miles west and 50 miles north of his house. Manuel picks up his friend who lives 15 miles south and 10 miles east of Manuel's house. How far away are the two boys from the resort? Did they give us a picture to look at here? First thing you need to do on any geometry problem, if they don't give you a picture, you must draw one. Test next Friday, questions that I don't give you a picture on, there's a spot on there and it says draw me a picture, and that does count for points. So you've got to get into the habit of drawing pictures for me here. So I'm going to draw an XY axis here. Please add this on your page. I know you only have so much room, but this is super important and definitely worth the paper. All right, so here's my x-axis. Here's my y-axis. But they didn't give me directions with x and y. They give me directions with north, south, east, and west. Where's north on this? Yep, top of the y-axis. Here's north. So where would south be? Down, bottom of the y-axis. Where's east? On the right. So here's east, and so west is going to be on the left. So since I'm putting this on a coordinate plane, west means I'm moving in the negative x direction. East would be the positive x direction. South would be the negative y direction, and north would be the positive y direction. Let's do the ski resort first. We're going to put an ordered pair on our picture for the ski resort. 20 miles west, is that left or right? Left. And 50 miles north, up. So 20 miles west, 50 miles north. So somewhere like right here. Here's the ski resort. And I'm going to write an ordered pair to go with it. How far to the west did we go? 20 miles. Since I went left, it needs to be a positive 20 or a negative 20? Negative 20. So I went 20 miles west, and then I went which way? 50 miles north, which would be up 50. So positive or negative 50? Positive 50. Since that's the first point that we plotted, are you guys okay with calling that x1 and y1? And then Manuel's friend, we're going to go back to the origin. And we're going to go from the origin to where Manuel's friend lives. Manuel's friend lives which way? South 15 miles. So from the origin, I go up or down? Down. And then which way? East. How far east?
15 or
10. So like here. Here's the friend. What would this ordered pair look like? 10 and negative 15. 10 to the east, 15 to the south. So that's going to be my x2 and y2. Since I don't have named points here, it's not like I'm finding the length of segment ij, but I still want that distance. I'm going to do dist for distance equals, and then I'm going to put in my big, long square root sign here. All right. I need my run. We're going to take that and square it. So I do x2 minus x1. What's my x2? 10. Minus x1. What's my x1? So inside parentheses, negative 20. Plus, and then my next set of parentheses, this is where my rise is going to go. We're going to take that and square it. So I need y2. What is y2? Negative 15 minus my y1, 50. I'm going to grab my calculator and start simplifying things here. When I subtract a negative, let's start with that. Subtracting a negative would be what? Adding. So I have 10 plus 20 here, which is 30. So I have 30 squared plus, what's negative 15 minus 50? Negative 65. And now if I haven't pulled out my calculator before now, I definitely need it now. What is 30 squared? 900. Plus, please make sure you have parentheses here because we know it's going to come out to be a positive number. Negative 65 squared, or negative 65 times itself. $4,225. So I add 900 and 4,225. 5,125. And then what do I need to do? Square root. So I'm going to grab my calculator. I'm going to square root that. I'm sorry, you said how much? 71 point, and then I didn't hear the decimals, I'm sorry. 5.9 or 5.8 or 5.89. I'm going to do 71.59 on the line up here because there's only so much room up there. 71.59 miles away from the ski resort when he goes to pick up his friend. I want you guys now to fill in the missing pieces on example number 4. Now that we've walked through one together, I want you to fill in the missing pieces on number 4 and find that correct answer. So we're up above the check that we just did. We're kind of going backwards here. I want you to do the problem above what we just did. And we'll check in about, I'll give you guys 2 or 3 minutes to fill in those blanks, and then we'll check that. All right. One of the things I want to point out, and I made mention of this when we were doing the check problem too, but notice there's step 1. What do they say you have to start off by doing? Draw a diagram. If you're not given a picture on a problem, especially when you're looking at the homework, no picture, you have to draw a picture. Again, I'm looking for that for points on the test. Yes? Yes. So like if you're gonna draw me a picture, like on that last one where we just had to put the dots, we didn't have the grid in the background, I just basically wanna see a model for what you're working with. I'm not grading your graphing necessarily, I am grading that you have a model to work from. Does that answer your question? Awesome. All right, so you have to draw a diagram first. And from there we decide our point 1 and our point 2. They listed what we're gonna use for x1, y1, x2, y2. What are we going to fill in here for x2? 435.3. What about back here in the place of y1? 151.6. We need to subtract those x's. 435.3 minus 212. What do you get when you simplify that first set of parentheses before you square it? 223.3. That's coming from this part right here. And then they did this second bit of subtraction for us. They squared the 223.3 and they got 49,862.89. What did you get when you squared the 159.7? Yes, 25,504.9. 0.09, sorry, thank you. 0.9. No, thank you for correcting me. And what did we get when we added those two together? You said 98? 75366.98. And then when we square root that, we get about what? 274.5. Take it out two places for me. 53. Yep. 274.53. Very, very nice work on the lesson today. Homework's due on Monday. You guys have learned everything you need to now to be successful on that homework. Yes, you're going to turn the warm-up into the tray before you leave the room. Real quick, what next week looks like. We have one more section and therefore one more homework to cover before your test. We'll do that on Monday and Tuesday. We'll do it over those 2 days. Wednesday and Thursday next week, we're going to review for your test. So Monday, Tuesday, last 2 lessons. Wednesday, Thursday, review. Test is on Friday. Have a fantastic rest of your day. Please don't forget to turn that homework in. Bell rings in about a minute. Do not line up at the door, but if you want to go turn that bell work, that warm-up page in, please do so. Also, calculators back in the container. If you gave me your ID because you had it with you today, please make sure to retrieve that. And I hope you guys enjoy your weekend.